All right, here we are back on our Unit 6 homework. Today we're going to be working on pages 3 and 4, so let's just get into it. First part is just filling out our word bank. Metals tend to blank electrons. So metals, what do? I like to tell my students metals, how I remember this is by saying metals go meow and cats lose lives. That's how it's a silly little saying, but it works. If you can just remember, metals go meow, cats lose lives, because, you know, they have 9, so they can lose them, and they're positive, like little cat paws, right? That can help you, you only have to remember one of those. We'll give you +3 points for writing that down. So, metals go meow and cats lose lives. So metals tend to lose electrons, forming positive ions, called cations. Nonmetals are going to do the opposite. So nonmetals are going to gain electrons, form negative ions called anions. And in an ionic bond, electrons are transferred. Okay, that's what the gaining and losing is. So one will lose and the other one will pick it up. They're transferred from a metal to a nonmetal, creating oppositely charged ions. Okay. Another term for the charge of an ion is called our oxidation state. Remember that when we had to memorize those? I know you do. Just haven't thought about it in a while. So yeah, write that down and you'll get the +3 points. Give it a little circle. All right, let's go into some of our naming rules. Okay, we want to check first if I'm just going to start with number 1. Right? First thing I want to do is look at the first element. If I notice that this is a metal, then I want to make sure I'm using my ionic rules. Sodium is a metal, okay, Na. So that means I want to use my ionic rules, and then I need to think to myself, does this need a Roman numeral? Is this located in the transition metal area? Sodium is not. Okay? Sodium is not. This was a student-made brain dump, but I love it. So, sodium's right here. It is not in this green zone. Okay, those are the only things that need Roman numerals. Not everything. A lot of the periodic table, but not everything. Okay, sodium's right there. So I am not going to use a Roman numeral in there. Don't just throw it in for fun. Almost right is wrong. So I'm just going to name it sodium fluoride. Pretty much everything except for some of the polyatomic ions will get that IDE ending. So that's a good bet for the second one. Let's do, I don't know, let's see. How about this iron? Okay, iron. Where is iron located? Right there, in the green. And what does it say? It must have a Roman numeral. So if it is in this green area, it needs a Roman numeral. Iron needs a Roman numeral. Where do we get that? We get it from the anion. That's where we're getting that. So I am not going to use this 2 as my Roman numeral. That's not correct. And almost right is wrong in chemistry. Look to the anion. That will almost always, about probably 75% of the time, give you the correct Roman numeral. So this is going to be iron 3. The 3 again comes from here. Oxide. And let's talk about another area here. Let's look at problem number 7. Aluminum. Aluminum is in yellow. That means it's in the exception block. If it's in the exception block, it does not need a Roman numeral. So right here, no Roman numeral needed, and also these first two columns. Okay, for our exception block, you're just going to use the ones place digit to give you that charge. So the 11, you take that plus 1, plus 2, plus 3. Here's the aluminum, plus 3. So it does not need a Roman numeral. It has a plus 3 charge, but that is not even necessary in the name. You can name it just like you name the group 1 and 2. It is understood. You don't need a Roman numeral in there. It's just aluminum. All right. And don't panic when you see something like SO4. So we do have, and I will grab that. You get the list of polyatomic ions. You just have to know where to find them. Don't try and split it up and say it's, oh, sulfur, oxygen. Nope. If it's inside a parenthesis, you need to use that as your signal to look at the polyatomic list and find it. It's SO4, and all I have to do is find it on my list, copy that name down exactly. It's aluminum sulfate. All right. So now we can go do the same exact thing, but in reverse, basically, to write our formula. It is a 4-step formula. So I'm going to say plus 2, 4-step formula. All right, so step 1. We're looking at a metal here. That means we're going to use our ionic rules. Step 1, you're always going to write out your symbols. Step 1 is symbols. The symbol for aluminum is Al. The symbol for oxygen is O. That's step 1. Step 2, you're going to write in your oxidation numbers. You had to memorize these, but in case you've forgotten, because it's been a while, plus 1, plus 2. Transition metals is going to vary. Exceptions, again, you're going to use those plus 1, plus 2, plus 3. Aluminum is an exception, so it has a plus 3 charge. Oxygen has a minus 2 charge. I know that from my anions going backwards. Minus 1, minus 2, there's oxygen. Minus 2. Just kind of thinking how far away, how many more does it need to get to 8? It's at 6. It needs 2 more. Electrons are negatively charged, so that's why it's a minus 2. And then they're going to switch places. So we'll say crisscross, jump, jump, right? So that 3 from the aluminum is going to go over to the oxygen. The 2 is going to go down to the aluminum. And when they jump down, they jump so hard they don't need to take the charges with them. So that is how I got my formula. Now, what if there is a Roman numeral already in there? Well, good. That just makes your life easier, because once you write out your symbols, you already know the charge, because that's what the Roman numeral is telling you. It's telling you it has a plus 3 charge. You don't even have to think about it. It's right there. The bromine is, again, you should have these memorized, but if you've forgotten, okay, subtract back once you get to the anions. So the bromine is right there. It is a minus 1. And then, again, we have to crisscross, jump, jump. That's always included in this formula writing step. So the 3 is going to go down to the bromine. The 1 is going to go down there, although you don't have to write out 1s in chemistry. Usually we don't. So your final answer would be AuBr3. All right, what if it is in groups 1 or 2? You might be wondering. Like number 13, right? That means you don't have to worry about it. It's in group 1 or 2. It has a set charge. Magnesium has a plus 2 charge always. Okay, magnesium. Nitrites. Remember to look at your endings. If it ends in ITE, then you should be using your polyatomic ion list. Okay, IDE means it's just a regular old thing on the periodic table. If it ends in something funky, like ites or eights, it's probably a polyatomic ion. There is nitrites. You just have to find it on the list. You don't have to memorize these. So nitrites is NO2 with a minus 1 charge. And again, you have to crisscross. Crisscross and jump, jump. When you jump down, the charges do not come with you. Okay, so we crisscrossed and jumped down. All right, so gonna keep going with this. What is the name of the compound BaPO4? So first of all, you have to know that Ba is barium, but you get this list. You don't have to have these. There it is. There's barium. So barium. But then I want to be looking at this PO4. Okay? The parentheses should be your hint. If you see a parentheses there, it's a polyatomic ion you're dealing with. So then you don't have to guess. You don't have to memorize it. You just need to know where to find it. There it is. It's barium phosphate. Barium does not need a Roman numeral. It is not in the Roman numeral area. It's right there. It's not green. Okay? So this is barium phosphate. And what is the formula for beryllium oxide? Again, 4-step formula. Automatically you can eliminate Ba. That's barium. Okay? So beryllium. Where is beryllium? You don't want to confuse it with barium, right? Beryllium's up here. Be is our symbol, and then we're going to start to fill in my charges. Okay, I wrote out my symbols. That's step 1. Step 2 is charges. Beryllium has a +2 charge. Oxygen has a -2 charge. And the last step we actually haven't talked about because we haven't needed to yet is reducing when you can. I can reduce this, and I have to in order to get the right answer. If you can reduce it, meaning you can divide it and still come out with a whole number, then you must for an ionic compound. Okay, 2 divided by 2 is 1, so I need to pick this answer. If you leave it unreduced, then you're wrong. Almost right is wrong. Okay, almost right is wrong. Circle that for a +2. All right. Now we're going to look at our prefixes. Where do we use prefixes? We only use them for covalent compounds. Or, I'm sorry. Yes. Yeah. When you are only dealing with covalent, meaning 2 nonmetals, that's where we want our prefixes, not for an ionic compound. Okay? So, fill that out. Mono, di, tri, right, etc., etc. Tetra. All right. And I will let y'all finish these up. Yeah, I'll let y'all get the rest of those in there. All right, I'll give you penta. Actually, I'm going to give you 6 because I'm feeling generous today. Hexa and hepta tend to be ones that students mix up, especially 7 because it's not a very common one. Okay? Octo, think about an octopus. Nona, it's the only one that starts with a 9. And deca, think about a decade, just 10 years long. So use what you know from real life. That usually is helpful.